Hello everyone and my dear friends. Today we are going to learn topic number 9, current electricity for 12th standard. That is the basic idea about the current electricity. That is, we have explained the basic idea, that is first current, second resistance, and third potential difference and their relation. What is meant by current? That is, suppose that Q is the charge and T in time T, the current flowing through the conductor is given by Q by T, that is the rate of flow of charge is called as the current. Unit of current is ampere, unit of charge is coulomb, and unit of time is second. Coulomb per second is called as the ampere. Next, resistance. What is meant by resistance? The opposition to the flow of electric current. The opposition to the flow of electric current is called as the resistance, and it is denoted by R. Unit of resistance is equal to ohm. Next, what is the potential difference? Potential difference is represented by V. The energy spent by, suppose that this conductor which is connected to the electromotive force, that is the resistance of this conductor is equal to R. Electromotive force is equal to E, which is connected to the conductor. Then energy spent by the source of electromotive force to overcome the external resistance once complete round circuit is called a potential difference, and unit of potential difference is volt. This is the basic idea about the current, resistance and potential difference. The relation between them, V is equal to I into R. With the help of this formula, we can determine the voltage, current and resistance. Also, this relation is called as the Ohm's law. This is the basic idea about all these three quantities, that is the current, resistance and potential difference. Now we have to start the current electricity. It is Kirchhoff's law. There are two laws. First law is called as the current law. Current law. It is also called as the loop theorem. What is current law? Mathematical statement: algebraic sum of the electric current at any junction is equal to 0. I takes value from 1 to n. If the number of conductors which are connected at a junction, suppose that we have to connect the 5 conductors or 6 conductors, first, second, third, fourth, fifth and sixth. These are the 6 conductors which is connected to common point. That point is called P is called the junction of the conductor. That is, the current flowing through the first conductor is equal to I1, second conductor is equal to I2, third I3, fourth I4 and fifth conductor current carrying is equal to I5 and sixth conductor current carrying I6. Then algebraic sum of the electric current at any junction is equal to 0. Then we have to apply the sign convention. There are two sign conventions. First sign convention, the current reaching to the junction is taken as positive. That is, the current approaching or reaching to the junction is taken as positive, while current leaving the junction is taken as the negative. Therefore, we have to apply this sign convention to this diagram. Therefore, we can write the current flowing or current reaching to the circuit and leaving the circuit or leaving the junction can be written as I1 is taken as positive. Therefore, I1 minus I2 current leaving the junction plus I3 minus I4 plus I5 minus I6 is equal to 0. That is minus I6 is equal to 0. Therefore, this we can write here I1 plus I3 plus I5 is equal to I2 plus I4 plus I6 is equal to 0. Sorry, not equal to 0. That is the I1 plus I3 plus I5 is equal to I2 plus I4 plus I6. From this equation it is clear that total current arriving the junction is equal to total current leaving the junction. Hence, algebraic sum of the electric current at any junction is equal to 0. This is the current law. We can now explain the Kirchhoff's second law. Second law, it is also called as the voltage law. Voltage law. For this case, we have to draw the diagram applying the sign convention, and mathematical formula can be written, and we show that the voltage law second. Mathematical statement for voltage law: algebraic sum of the electromotive forces and potential difference in the circuit is equal to 0, or algebraic sum of the potential differences in the circuit and all the electromotive force, or summation of electromotive force is equal to 0. This is the mathematical statement for voltage law. We have to prove this law. Potential difference plus electromotive force is equal to 0. For this case, we have to draw the diagram. That is, the diagram consists of large number of resistances. Number of resistances, that is, we have to draw the diagram here. First resistance, second resistance, electromotive force, next resistance, and electromotive force. Positive, negative electromotive force is equal to E1, electromotive force E2, and we are also connect the resistance here. Label the diagram A, B, C, D, E, F and A. This resistance is equal to R1, this resistance R2, R3, R4 and R5. The current flowing through the circuit is equal to I1. Here I3 means I1 plus I2. The current flowing through this resistance is equal to I2. The direction of conventional current is in this way. Direction of current in this circuit is equal to in this way. Then we have to consider, that is, the number of resistances which are connected in the circuit, to electromotive forces also connected in the circuit. Then in this closed circuit consists of 3 loops or 3 closed circuit. First, A, B, E, F, A. A, B, E, F, A. This is the first closed circuit. Second, B, C, D, E, B. This is the B, C, D, E. And third, A, B, C, D, E, F and A. These are the 3 closed loop or closed circuit contains in this given closed circuit. Therefore, we have to apply the Kirchhoff's law for all circuit, Kirchhoff's voltage law for all circuit, and we can write the further equation. Before writing the equation, we can explain the sign convention. We have to apply the sign convention. What are the sign convention? That is the first sign convention. First, that is, loop is traced in this fashion: I1, A, B, E, F, A. the conventional current flowing in the direction of traced loop, then potential differences are taken as negative. And if the potential difference are taken as the positive if we trace the loop against the direction of conventional current, that is which is taken as positive. Next, the electromotive force which current flows from negative terminal to the positive terminal in the source, which is taken as positive. Second sign convention, that is the current which flowing from negative terminal of the cell to the positive terminal in the direction of electric current is taken as positive, while if the current which flowing from positive terminal of the source to the negative terminal of source, which is taken as negative. With the help of these two sign convention, we have to write the equation. First we apply the equation, or first we apply the voltage law to the first closed loop A, B, E, F, A. Therefore, we have to write here by using sign convention. That is, this current which flowing from, we have to consider A, B, E, F, A closed loop. Therefore, we have here write minus I1 R1 current in conventional current. Second, I minus I3 R3. Next, minus I1 R5 and plus electromotive force negative to positive, which is taken as positive. Therefore, plus E1 is equal to 0. Therefore, we have to write, that is E1 is equal to I1 R1 plus I3 R3 plus I1 R5, which shows that left hand side consists of only electromotive force and right hand consists of only potential differences across R1, R2, R3, R1, R3 and R5. Therefore, algebraic sum of the electromotive forces in the closed circuit is equal to total potential difference of the circuit, means algebraic sum of the potential differences in the circuit and electromotive force in the circuit is equal to 0. This is the second law, which is called as the voltage law. Similarly, we can apply for the loop B, C, D, E, B. We can write this formula, current flowing in this way. In this case, we take B, C, D, E, B, then I2, R2. I2, R2 in this minus E2 and plus I2, R4, and in this case plus I3, R3. I3, R3 is equal to 0. This equation can be written as E2 is equal to I2, R2 plus I2, R4 plus I3, R3 is, from this equation it is also clear that electromotive force is equal to potential, sum of the potential differences. From these two equations, this equation, we can show that algebraic sum of the electromotive forces and potential differences in the closed circuit is equal to 0. This is the Kirchhoff's second law. We can prove the Kirchhoff's second law. Then this Kirchhoff's law or voltage law, Kirchhoff's first and second law, which is applicable for AC and DC circuit. AC and DC circuit, Kirchhoff's law is mostly accurately is applicable for DC circuit and low frequency AC circuit. Therefore, we have to explain the idea about for solving the problem by using Kirchhoff's law. For solving problem by using the Kirchhoff's law, following steps are followed. Following steps can be followed when we solve the problems by using the Kirchhoff's law. First step 1. Choose the direction of the current. Choose the direction of current. First we have to choose. Second, reduce the variable in the circuit by using the Kirchhoff's law, Kirchhoff's first law. Reduce the variable in the circuit by using Kirchhoff's law. We have to determine the number of closed loops. To determine the number of closed loop in the given circuit, and apply the voltage law to all the independent loops. That is, all the independent loop we have to apply the Kirchhoff's law, and lastly we have to solve the equations obtained simultaneously. Equation we have to solve simultaneously. Then we have to explain the meter bridge or Wheatstone's bridge. Okay. This is diagram for Wheatstone's network condition or Wheatstone's bridge. This Wheatstone's bridge consists of 4 resistances P, Q, R, E, R and S. These resistances are connected in such a way that they form the quadrilateral A, B, C, D. A galvanometer is connected between the point B and D. Electromotive force E, K, which is connected between the point A and C. Then I is the current flowing through the circuit. Then at point A, I1 is the current flowing through the resistance P. I2 is the current flowing through the resistance S, and I1 minus Ig current flowing through the resistance Q, I2 plus Ig current flowing through the resistance R. Then we have to consider, that is, the total current flowing through the circuit is given by I is equal to I1 plus I2. Next, consider, that is, this circuit consists of number of loops, closed loop. We have to consider A, B, D, A. This A, B, D, A, and second B, C, D, A. B, C, D, A. These are the 2 loops which consist in the given diagram. Then applying the sign convention. Applying the sign convention to this circuit for the loop A, B, D, A, we have to write the equation, that is minus I1P. This is the minus I1P. Next, minus IgG, and this is the positive, plus I2 S is equal to 0. Equation number 1. Similarly, we apply the voltage law or Kirchhoff's law to the loop B, C, D, B. Therefore, we have to write second equation, I1 minus Ig into Q in this, plus I2 plus Ig into R, and plus IgG in this is equal to 0. Equation number 2. That is, bridge is said to be balanced, or Wheatstone's network condition is balanced when current flowing through the galvanometer is equal to 0. In this case, G is the resistance of galvanometer, Ig is the current flowing through the galvanometer. That is, when key pressed and current flowing through the circuit, at point A, I1 flowing in this fashion, I2 flowing in this resistance, and at point B and at point D, potential difference equal, therefore current flowing through the galvanometer is equal to 0. This is the network condition, that is Ig is equal to 0. Substitute this value Ig is equal to 0 in equation number 1 and equation number 2. Therefore, we have to write here minus I1P plus I2S is equal to 0, or equation number 3. Similarly, equation number 2 can be written as minus I1Q plus I2R 0 is equal to 0, equation number 4. Therefore, equation number 3 can be written as here I1P is equal to I2S, and equation number 4 can be written as I1Q is equal to I2R. Divide this equation, suppose that this equation number 5, this equation number 6. Divide equation 5 by 6, therefore we have to write here I1P is equal to I2S divided by I1Q is equal to I2R. I1 get cancelled, I2 get cancelled, therefore P divided by Q is equal to S divided by R. This is the Wheatstone's network condition. With the help of this formula, we can determine the any resistance if we have to given the 3 resistances. Okay. Next point, we have to explain the idea about the Wheatstone's meter bridge. We have to explain the idea about the Wheatstone's meter bridge. Before going to meter bridge, we have to explain uses of Wheatstone's bridge. First use, Wheatstone's meter bridge or Wheatstone's network condition is used for measurement of unknown resistance. Second, it is used to determine the resistance of galvanometer G. Next, it is also used for measurement of inductance, capacitance and impedance of the circuit. It is also used for to measure the low voltage, very low resistance. Very low resistance can be measured with the help of Wheatstone's bridge, and last also it is used to measure the strain measurement. We have to use the Wheatstone's network. Today we will stop here, and the next point we have to discuss Wheatstone's meter bridge.